Hello, this is the Chapter 1 lesson. In Chapter 1 there are a lot of important basic definitions and concepts, most of which I'm going to allow you to simply read from the book and study on your own. In this lesson I'm going to hit some of the most important topics and definitions. First thing we need to talk about is, why do we take statistics? Well, there are at least three reasons we need to take this class. First of all, you just need the credit. You may not like math class, but you need the credit, and that's the only reason you're here. I can understand that. Second of all, it's needed for your major. A lot of different majors require statistics. Business, physical sciences, behavioral sciences, a lot of different majors require it, and there's a reason. That's because statistics is very useful in a lot of different fields. Third, and most importantly, it's so that we can become a better informed consumer and citizen. Statistics are used by advertisers, by politicians, by pundits, and oftentimes they're misused. Having a good understanding of statistics will help us to understand when statistics are being used and what they mean, and maybe when they're being used improperly as well. So our goals for this class is we're going to cover a wide range of topics. For each topic we're going to ask ourselves several questions. What are we doing, and why are we doing it? We're not going to crunch numbers just for the sake of crunching numbers. We understand what we're doing and why we are doing it. Third, we're going to ask, when can we do it? We're going to stress later on that you can't simply blindly plug any set of numbers into any formula and expect to get a valid result. There's some requirements that have to be met. Fourth, how can we do it? Most of the time we're going to use a calculator to crunch the numbers. We're not going to be memorizing a lot of formulas or doing a lot of work by hand. And then lastly, and most importantly, what does this mean? Again, we're not going to crunch numbers just for the sake of crunching numbers. We understand what those results are telling us. So first, a very important definition is data. Data are observations such as measurements, genders, survey responses that have been collected. Notice this does not say that data are simply numbers. They can be numbers, but they can be lists of words like genders. They can be survey responses like letters A, B, C, or D. They can be numbers, but they don't have to be. A little grammar here, the word data is plural and the word datum is singular. Oftentimes we misuse the word data as a singular noun, but it's actually plural. Data falls into two general categories. First, we have quantitative, and those are data that are in the form of numbers, consist of numbers representing counts or measurements. The other type is qualitative, and that's data that does not involve numbers. It's lists of words, or in general, it's data that can be separated into different categories that are distinguished by some non-numeric characteristic. The important word there is non-numeric. Quantitative data is further divided down into two subtypes. We first have discrete, where the numbers must be of a certain type, like integers or whole numbers. For example, if we go to different classes and write down the number of females in those classes, that's going to have to be a whole number. You can't have half a female in a class. Continuous data are those that don't have to be of a certain type. They can take on any value within some range. So for instance, weights of fish in a lake. If I weigh a fish from a lake, it could weigh anywhere from 0 pounds up to 50 pounds, or whatever the heaviest fish in the lake is. It doesn't have to be a whole number or of any certain type. So then statistics is a collection of methods for planning studies and experiments, obtaining data, and then organizing, summarizing, presenting, analyzing, interpreting, and drawing conclusions based on the data. Again, notice that it says statistics is more than just number crunching. You start off with planning how you're going to gather your data, and then you actually gather it, and then you have to organize, summarize, present it using things like graphs. Next, we analyze it. That's where the number crunching comes in. And then the last step would be to interpret and draw conclusions. So again, it's a very broad definition. It covers a lot of different things. So as an example, consider all students at Concordia University. And a question we might ask about these students is, what proportion or percentage of these people are taller than 5 feet 4 inches? The word proportion and percentage mean essentially the same thing, and we're going to use the words almost interchangeably. Proportion is actually the decimal form of a percentage. A proportion will always be somewhere between 0 and 1. So before we start to analyze that question a little more, we have to define a couple of terms here. First is population. Population is the complete collection of all elements to be studied. Population we typically think of as being a group of people, but it doesn't necessarily have to be. In this case, our population is a group of people. It's all students at Concordia. But population is everything we're interested in a particular situation. If we're interested in fish in a lake, then our population is fish in a lake. If we're interested in M&Ms in a bag, then our population would be M&Ms. So to find the exact answer to the question, to find the exact proportion of that population that is greater than 5 feet 4 inches, we would have to measure all 1,000 or so students at Concordia, count the number that are taller than 5 feet 4 inches, and divide this number by 1,000. That would give us an exact answer to our question, but that's very difficult, if not impossible, to do, again, because it would require me to measure 1,000 people. So instead of looking at the entire, I got ahead of myself. If we were to do that, this proportion that we would calculate is what we call a parameter, and that is a generic name for a numerical measurement obtained from surveying every member of the entire population. Now, this is what we actually want, but this is very difficult, if not impossible, to obtain. So instead of looking at the entire population, we're going to only look at a sample of the population. A sample is a sub-collection of members selected from the population. An example might be just 30 students from a statistics class. Now, the difference between a population and a sample is what the field of statistics is really all about. I want to know something about my entire population, but that's difficult, if not impossible, to determine. So instead, I'm going to look at a sample or a sub-collection. Again, here my population is all 1,000 students at Concordia, but I only look at a sample of maybe 30 students from a class. Okay. So let's say that I go to these 30 students, I count the number that are taller than 5 feet 4 inches, and 6 of them are. So I take 6 divided by my sample size of 30, and I get a proportion of 0.2, which is equal to 20%. Now, this number of 20% is an example of what we call a statistic, which is a numerical measurement obtained from surveying every member of a sample. Now, this is relatively easy to obtain because it only required me to look at these 30 people in the sample. My hope is that this statistic is a good estimate of the population parameter, which is what I really want to know. Now, this sample that we took of 30 students from a statistics class is an example of what we call a convenience sample, and that's simply a sample that is easy to get. This is statistics class. I got these people around me, and it was very easy to get. However, it may not be a quote-unquote good sample, and what we mean by it not being a good sample is that it may not accurately represent the population. Now, what that means in more technical terms is that our statistic of 20% may not be a good estimate of the population parameter. If my sample doesn't represent the population, then my estimate of the population parameter may not be very good. So when we choose a sample, our goal is that it should accurately represent the population. Now, exactly what we mean by accurately represent the population is a little bit subjective, but 30 students from a statistics class is not going to be a good representation of my entire population. That sample is probably going to exclude a lot of majors or types of people, those types who don't take statistics class. There's an important quote from the book. If sample data are not collected in an appropriate way, the data may be so completely useless that no amount of statistical torturing can salvage them. Again, if we don't collect the data in an appropriate way, then we can't crunch the numbers enough to get a good okay, so we had this convenience sample that we decided was not a good representation of our population. So another way we might try to get a better sample is to randomly select 3 different classes and survey each student in those classes. Maybe we take one statistics class, one biology class, and one art class. That would be what we call a cluster sample. Clusters where we divide our population into different clusters or groups, and we select a few of those clusters. Now the benefit of this is that we get a wider range of students. We get more than just statistics students, and that's good. So it probably will be a better representation of our population. Okay. Another way we might do it is to stand out in the hall and select every 5th student we see until we collect maybe 50 or 60 students. This is what we call a systematic sample, is because we are collecting our sample in a very systematic way. Now again, the benefit is we get a wider range of students. It's not just students from one type of class, it's students just walking out in the hall. So it's probably a better representation of our population. Okay. The next type, and it's the most important and the best type of sample we're going to talk about, is what's called a random sample. And the idea here is that members from the population are selected in such a way that each individual member in the population has an equal chance of being selected. So that means that we don't focus on any one type of student, nor do we exclude any one type of student. Okay? And this again is the best type of sample, and it's going to be the only type of sample that we're going to allow in our analysis. But the problem is that it's very difficult to get a true random sample of our population. It's the best, but very difficult to do properly. So if one way to get a random sample, a true random sample of our entire population, is to get a list of all of our students. Maybe go to the student directory or get a list from the registrar, and then we assign each of those students a number from 1 up to 1,000, or however many students we have in our population. And then we use a computer to randomly select 30 numbers between 1 and 1,000, and then we survey those students. So again, our computer randomly selected those students. And this sample that we get would be a sample of 30 truly randomly selected students. The main point of Chapter 1 is that the method used to collect data is absolutely and critically important, and we should know that randomness is particularly important. If we don't have a random sample, then we're not going to be able to use a lot of our tools and formulas that we'll learn later on in the semester. We have to have a random sample in order to analyze our data properly. And again, this second sentence here we've seen before. If the sample data are not collected in an appropriate way, the data may be so completely useless that no amount of statistical torturing can salvage them. So that's all the topics I wanted to cover from Chapter 1. Your assignment is to read the first chapter, which is pages 1 through 33, and you can do that by going to the ebook section of Course Compass and start reading. Once you have read those, do the Chapter 1 homework at Course Compass.